So you do laptop?
They give me now here we have electron drift and electron diffusion. Okay, diffusion means what? Motion of particles from high concentration area to low concentration, high concentration region to low concentration region. That is said to be diffusion, not diffusion. Diffusion means in chemistry we have means from a small hole, escape of gas from a small hole is said to be diffusion. Okay, diffusion means motion of particles from high concentration region to low concentration region. Like suppose in N-type semiconductor, high concentration particles are electrons. In P-type, high concentration are holes. Okay, it's like that. So high concentration to low concentration. Now here two different processes I have to explain. One is drift and the second one is drift and diffusion. Okay, drift and diffusion. Now here, suppose if this is a P-type, when a P-type substrate or it is brought very close to N-type substrate, then what will happen? You get a PN extender. This is P and this is up. So this is negative. This is okay. Okay, so here we have electron drift. This is electron diffusion. Similarly, this is hole diffusion. Hole diffusion. Holes will move from hole P to N. And electron diffusion means electron will move from N to P. Okay. And here this is said to be hole drift. And next one is what? This is said to be depletion region. This is said to be depletion region. Now, example I will give. Now suppose there is a boys class. Okay. This is a class which all are boys. And only one girl is made to sit in the class. Yeah. She's not comfortable, right? Okay, she's not comfortable. Yeah, the same thing happens when vice versa. So it's not, they are not comfortable. The same thing. Now they are said to be minority. In your, suppose in a boys class, if you make one girl sit, that means she's a minority charge carrier, and you people are majority charge carriers. Same way. So here in N-type semiconductor, majority charge carriers are electrons, and minority charge carriers are holes. So all the holes, when you bring a N-type semiconductor or substrate close to a P-type substrate, immediately what happens? All the minority charge carriers are ready to move. Understood? Suppose example I will give here. Suppose there is a what do you call a metallic sphere. Metallic sphere stands on a insulated material. But now the charge cannot flow, right? There are charges on this sphere. Charges cannot flow. But if I put like this, what will happen? Charges will flow from the edge, right? Charges will flow from this sharp edge.
Yes.
Understood? So they are also looking for that only. These charges are looking here. The minority charge carriers are looking to escape now.
Okay.
From N-type material. Similarly, in P-type material, electrons are ready to escape. Understood?
Yeah.
But when you brought it together, they formed a region of minority charge carrier. All minority charge carriers formed a region. That region is said to be depletion region.
Okay.
Okay, that is how much? 0. How much? What is the thickness of that?
0.01 to 0.08.
Yeah, the depletion region thickness is 0.01 micrometer.
So where depletion regions?
This region. Minority. This is a minority charge carrier.
Okay.
So that forms a depletion region. Understood now? Now it also has a barrier, a potential. We say that potential barrier. This also is known as potential. This region is also known as potential barrier. Means why? Because a small potential is developed. A small potential is developed. So what will happen? Now to make you understand this, I have to explain what are the passive components and active components. Passive components and active components. What are? So we have two types of components: passive and active components.
So we explain this minority charge carrier.
Which one?
This minority charge carrier.
Minority charge carriers means suppose in N-type minority are holes.
Yes.
In P-type minority are electrons. So when you connect them,
electrons will go to
electrons are ready to go. No, they cannot go. They are ready.
They are ready. Okay.
The holes are ready. They came to the edge corner.
Okay.
And electrons are also came to the corner now,
Yes, sir.
to the end. If you apply little potential difference, they start flowing.
This thing.
That's what it's called potential barrier.
Yeah.
The level.
They are ready to. They are now. They are just cross the Fermi level now.
Yes, sir.
But now they did not still enter the. You need to give that much energy. 0.01 electron volt of energy should be given.
Yes, sir.
Then only holes will go from N to P and electrons will go from P to N. What is exactly happening? This electron will come and sit here. Electron will go here. Finish. Understood now?
Yes, sir. Yes, sir.
So
Got
again,
it.
holes should be found on that.
Understood now. But this is going on now. Doesn't stop there. If you apply potential difference, this fellow will jump here, this fellow will jump here, this fellow like that, it keeps on going. Electrons will go on, keep on going in this. Got it?
Okay, sir.
They don't stop when you give potential difference. Understood now? Clear? That will form a potential barrier. But I want to explain what is a potential barrier here. So there are two types of components. One is passive components and active components. So when I speak about passive components, we have RLC, resistor, capacitor, and inductor. These are said to be the this passive component. And these active components are diodes and transistors. Diodes and transistors are said to be the active components. Okay. RLC, resistor, capacitor, and inductor are said to be passive components.
So
And
this
active.
part there for us.
This is not there, but to make you understand what is potential barrier, I am explaining this. Understood? So why there are passive components? Why means when you don't apply any potential, there is no potential difference initially in it. There is no potential difference initially in it, unless and until you apply any potential difference. Unless and until you apply any potential, there is no inbuilt potential, electric potential inside. But now in active components, not like that. There is already some potential difference developed because of this headache, because of the minority charge carriers. If you take a multimeter, or if you take a voltmeter, a micro volt or something like that, if you connect it here, then you can see there is some deflection in that one. Understood? Because there is some potential difference is developed now. Some potential is built up over there. The accumulation of positive charges in N side and negative charges in P side set up a potential difference across the junction that acts as a barrier. Yeah, very good. So he has given the definition here. The potential. Where I will put copy paste.
From Google to here.
Yeah. The accumulation of positive charges in N. You will find out faults only with everyone. Yeah. Okay. The accumulation of, I don't know how the teachers manage him in the school. Is he same in the school or he is just kept
It's
stuck?
like this
Sleeps.
full-time crack.
But his one thing specialty is that he's fair. He doesn't keep anything in his mind. That's the thing.
Yeah, I can tell about
So the accumulation of positive charges in N side and negative charges in P side set up a potential difference. This small potential difference is developed. That potential difference is acting like a barrier. That is said to be a potential barrier. Understood now? Clear, sir? Then it was a drift now. I'll try to explain the drift. Again, I will go back to the third chapter, electricity, current electricity.
So potential barrier and depletion region both are
Same. Depletion region means the region formed due to the minority charge carriers. That is depletion region. But the depletion region is producing some potential difference. That is why it is known as potential region.
minority in anti-pulse.
Minority in N and minority in P.
So what was the electrons was the minority.
Minority, yeah. Here electrons are minority. Here holes are the minority. Understood? They combine together and still they are not moving. They are in the static now. They cannot move unless and until you apply any potential difference. Understood? So that is itself producing a potential now. Understood? Clear? See.
So once you put the potential difference, the minority charge carriers will travel from P to N. This electrons from P to go to N. So then N is the negative charge. So N is negative, right? So won't it repel charge carriers?
No.
So N is negative, right?
Yeah, N is negative.
So the negative minority charge carriers from P, when they travel to N, won't it be repelled back to P?
No, that I will explain in forward bias and reverse bias. That is also there. Forward bias and reverse. For time being, because of this minority charges, a potential is developed over there. That is a potential barrier. But how it flows, I'll explain in forward bias and reverse bias. Understood?
Okay, sir.
Clear with you? Yes, sir. Now, means motion will be there. Now, motion of the electrons and holes will take place once you apply the potential difference. Okay. Now here we have drift. I will explain, which is in the third chapter, current electricity. Drift. You know what is the diffusion now? High concentration region to low concentration region. Understood? Electrons here, high concentration region. Okay.
So N-type has holes, right?
N-type has electrons. Excess charge carriers are electrons.
P is positive.
N is negative, P for positive.
N is excess electrons.
N is excess electrons, charge carriers are electrons, and P is charge carriers are holes.
Yeah.
Okay, but these are minority people. Understood?
So the minority of N would be holes and
Yeah.
P would be electrons.
Understood now? Clear?
Yes.
Okay. Now, I'll write the definition also. Here, what will happen? Before that, I would like to explain what is a drift thing. Now, in drift means, like suppose in first term, the current electricity, you might have seen this, like a wire is there, and a small potential difference is applied like this. So what will happen here? Electrons will drift. They will collide with each other, right? They will collide and they start moving in different direction. But finally, there is some displacement. That velocity is said to be drift velocity, right? Finally, because there is some displacement. That displacement by time is said to be the drift velocity. Understood? Means electrons are drifting. Is that clear? But you are applying the field in this way, right? Electric field is applied in this way. But holes are drifting, electrons are drifting in the opposite direction. Understood now? Electrons are drifting because positive is moving in this way. Electrons are drifting in the opposite way. Clear? So that is said to be drifting. So you keep that in the mind. Electron diffusion and electron drift both are in opposite direction. Electron drift and see here, look at this point. Electric field and electron, direction of electron, both are in opposite. That is the reason diffusion and drift both are in opposite direction. Clear now?
Yes, sir.
Okay. Then we'll go with the what is depletion region. Then I'll explain what is the potential barrier also. I'll write the definition. Then we can go ahead. I don't think so I'll be able to complete this, but anyways, we'll continue tomorrow. Okay. First, I'll write this definition of depletion region and space charge. So the other name of depletion region is space charge region. Depletion region or space charge region. Depletion region or space charge region. Now, a narrow region near the junction. A narrow region near the junction. A narrow region near the junction is depleted in mobile charge carrier. Is depleted in mobile charge carrier. In mobile charge carrier. A narrow region near the junction is depleted in mobile charge carrier. This is known as depletion region or space charge region, which is around 0.01 micrometer, very, very small. The thickness is very, very small. Next is barrier potential. Due to accumulation of charges, near the junction, an electric field is established. An electric field is established. An electric field is established This gives rise to electrostatic potential. This gives rise to electrostatic potential.
Electric field is
One second. Electric field is established because of it. See what is happening? When positive are here, negative are here, electric field is established, right? Positive to negative, like this. The field is established like this. That is giving rise to, we have the formula E is equal to VD, you know, or V is equal to E by D. A very important relation between electric potential and electric field. Whenever there is electric field, there is a potential. Electric potential is developed over there. Okay. Yeah. So that is said to be barrier potential. And thickness of depletion region is 0.5 micrometer. The thickness is, how much is the thickness? Thickness is 0.05 micrometer or 0.1 micrometer. Okay. Thickness is 0.1 or 0.5 micrometer. And the potential barrier for germanium, the barrier for germanium is 0.3. If you take for germanium, the value is 0.3 volt, and for silicon it is 0.7 volt. Okay, this much is the voltage developed for a P region and for a P. This will be asked. Okay,
So this is the barrier potential.
yeah, barrier potential for silicon and germanium. For germanium it is less, and for silicon it is more. Okay, no problem. So now we will stop here for now. Okay, we can
Abu
go.
Dhabi.
She's in Abu Dhabi.
It extends.
You message her?